I've got the cutoff scores. So the honor roll is 102 and the AMC floor is 108. So hopefully I'll get above 108 this time. So now each correct question is 6 points. Each skipped question is 1.5 points. So yeah, that means that if I want to do it, I guess 6 times the number of questions I get right. Okay. This has to be equal to 108. Of course, this isn't factoring in the wrong questions, but this is the minimum amount that I need to get right if I solve for Q here, which I obviously won't because we don't have time for that. By the way, this is the 2019 AMC 10A answer key. Today we're doing the 2019 10B. They're two completely different exams. So yeah. All right. Time to begin.
Okay, so here's the right.
Mm-hmm.
So, all right. It's not in the middle, so make it in the middle.
Yeah, okay. So, Olympiad had 2 containers. The first was 5/6 full of water, and the second was empty. He poured all the water from the first container into the second, in which the second was full of 3/4 full of water. What is the ratio of the volume of the first container to the volume of the second container? So x is 5/6a, and x is only 3/4b. So 3/4b equals 5/6a. We're trying to find a over b. So 6/5 times 3/4 b equals a. So a over b is 6/5 times 3/4, which is 18/20 or 9/10.
Okay, baby, good luck.
Thank you. Goodbye. Okay, consider the statement: if n is not prime, then n minus 2 is prime. Which of the following examples of n is a counterexample to the statement? Okay, so 11 minus 2 is 9. Now you might think, oh, that's a counterexample, but it said if n is not prime. So 15 could be a valid one, but let's see, 13, that's prime, no. 21 and 27 are the last 2 valid ones. 21 minus 2 is 19, which is prime, so no. But 27 minus 2 is 25, which is not prime. So if n is not prime, 27 is not prime, n minus 2 is prime. But 25 is not prime either, so, you know. A high school with 500 students, 40% of the seniors play a musical instrument, while 30% of the non-seniors do not play a musical instrument. What? Okay, so that means that 60% of the seniors don't play anything, while 30% of the non-seniors don't play anything. So 0.6 s plus 0.3 0.3 times 500 minus s is equal to 46.8%, so 0.468. So that means 6s plus 3 times 500 minus s is 4.68. I know 468 has to be divisible by 3 because digits sum up to 18. So let's see, 156. Okay. So that means that 2s plus 500 minus s is equal to 1.56. Wait, what? Okay, so let's say there are S seniors. So there are 0.6s plus 0.3 times 500 minus, And 46.8%, that's like 46.8 times 5. What's 47 times 5? 35 plus 200, 235. So then, my question to you is, what is 46.8 times 5? 234, obviously. Okay. So 6s plus 3 times 500 minus s. This is definitely divisible by 3 because its digits sum up to 9. There are exactly 280 seniors. So that means there are 500 minus 280 non-seniors, which is 250 minus 30 non-seniors, which is 220 non-seniors. So 70% of these fellows play a musical instrument. 220 times 7 over 10 is 22 times 7, which is 154. It's unexpectedly hard for question 3. 4. All lines with equation ax plus by equals c such that a, b, and c form an arithmetic progression pass through one common point. What are the coordinates of that point? So it's like ax plus a plus ny equals a plus 2n. So a plus n times y equals a plus 2n minus ax. So minus ax over a plus n plus a plus 2n over a plus n. Wait a dang second. Wait, oh dang it. N minus ax over n plus a. What I'm trying to do here is just plug in points, see if, okay, A. Okay. Triangle ABC lies in the first quadrant. Points A, B, and C are reflected across the line. Yeah, like it only flips you to the opposite side if you're in either this quadrant or that quadrant. It will flip you to the same quadrant if you're in one of these two. So that means A should always be true. B, triangles ABC and A prime, B prime, C prime. That literally has to be true because it's just a reflection, not a dilation. So B is also definitely true. The slope of line A prime, is -1. I mean, that happened with every single point reflected over y equals x. So C is certified. D, the slopes of line AA and CC, A prime and CC prime are the same. That has to be true. Lines AB and A prime B prime are perpendicular to each other. Now, I don't know about that, my fellow. Yeah, I wouldn't call these two very perpendicular, would I now? So no, E is definitely not certified. There's a real n such that n plus 1 factorial plus, oh, that's simple. You just divide by n factorial on both sides. That just gives you n plus 1 plus n plus 2 times n plus 1 equals 440. Or in other words, n plus 1 times n plus 3 is 440. What are the factors of 440? Well, 440 is 11 times 4 times 10. So it's 11 times 2 squared times 2 times 5. So 2 cubed times 5 times 11. So what are the factors? 1, 2, 3, no, 4, 5, not 6, not 7, 8, not 9, 10, 11. I would have thought it turned up by now. No, never mind, I wouldn't have. So 11, oh, it's probably like the two closest factors to each other. So like, for example, what's 440 divided by 20? 22. Oh gosh. So that means n plus 3 is 22, and n plus 1 is 20, so n is 19. So the sum of those digits is 10. Okay, each piece of candy in a store costs a whole number of cents. Casper has exactly enough money to buy either 12 pieces of red candy, so his money, M, is divisible by 12, 14 pieces of green candy, 15 pieces of blue candy, or N pieces of purple candy. And the piece of purple candy costs 20 cents. Okay. So what's the smallest number divisible by all of these, I guess it's asking. So what's their least common denominator? Well, the least common denominator of 12 and 14, as far as I know, would be 6 times 14, which would be 60 plus 24, or 84. So the common denominator of 84 and 15 is, well, both of them divided by 3. So 84 times 5 is their common denominator. Because 84 is a factor of 3 and 15 is also a factor of 3, but they don't share anything past that. So that would mean it's 420. And then finally, that already divides into 20, so we can ignore that. So 420 over 20 is 21. Now let's test the possibility of 20 times 18, 360. 360 does not divide 14, so that's that. Okay, B. The figure below So it's a square and 4 equilateral triangles, with each triangle have a side lying on a side of the square, such that each triangle has side length 2, and the third vertices of the triangle meet at the center of the square. The region inside the square but outside the triangle is shaded. What is the area of the shaded region? Let's get to work. Okay, so obviously, if this length is 2, this length is 1, which makes this height √3, which makes the side length of this entire fellow 2√3. So then, what's the area of each one of these triangles? It's s squared, so 4√3 over 4. So that means that the area of all of them combined is 4√3. Isn't it? Yeah, I personally really do believe that it's 4√3. And then this squared is 12. So I'll say B. Problem 9. The function f is defined by the floor of the absolute value of x minus the absolute value of the floor of x, for all real numbers x. What is the range of f? What the heck? Well, let's test some random number like, wait, let's see. So let's assume just for a second that x is positive. Well, if x is positive, it's got to be 0. If x is negative, however, that means we have the floor of minus x over here minus the negative floor of x. So it's like the minus floor of x plus the floor of x. Now, for a situation like 359.9, for example, the floor or negative 359.9 in this case. So the floor of positive 359.9 is just 359. The floor of negative 359.9 is 360. So that's -1. So it might be A, but it also might be C. So, and it can't be B or E or D, because the maximum distance between these two is always going to be 1 or -1, whatever you want to call it. Is there ever a situation where these two have a sum of +1? Probably not. Yeah, I'm gonna say no, so it's A. 10. In a given plane, points A and B are 10 units apart. How many points C are there in the plane such that the perimeter of ABC is 50 and the area of ABC is 100? What the heck? So you see, I learned something interesting during my interview with Stony Brook about the area of obtuse triangles, like this hot fellow right here. So if we call this, let's say, ABC, then the area of this triangle is just half AB times this length right here. So if I call this D, then CD. And obviously this is perpendicular to BD. So yeah, we're gonna try using that here. So in our coordinate plane, we'll take the simplest case that A and B are both on the x-axis and they're just 10 units apart. Then how many points C are there such that the perimeter is 50 units? So that means that BC plus AC has to be 40. Now thinking about it, this is currently 10, 0, and this is 0, 0. So that means that the square root of, let's call the coordinates cx comma cy. So then that means that the square root of the distance from BC is going to be 10 minus cx and then cy squared plus the square root of cx squared plus cy squared. This already has to be 40, which is a pretty outstanding requirement. But even more so, what else do we have? The area of ABC is got to be 100 square units. So this is my genuine attempt at this problem, and it's not going so well. No. So let's bring this to the other side actually to get 10 minus cx squared plus cy squared equals, if we square the other side, cx squared plus cy squared plus 40 squared is 1600 minus 80 root cx squared plus cy squared. But I did. So that means cx squared plus 100 minus 20cx is equal to cx squared plus 1600 minus 80 root cx squared plus cy squared. So, so 1500 equals 80 rad cx squared plus cy squared minus 20 cx. So 8 rad cx squared plus cy squared equals 1500 plus 20 cx. So squaring both sides, you get 64 root, did I miss anything? No. 64 times cx squared plus cy squared must be equal to, oh god, 400 cx squared plus 2250000. Need to put commas on such a big number. Minus 30,000 cx. What the heck? This is not an ideal situation. I'm really in a pickle, as you can see. Let's cut this down to 16 cx squared plus cy squared equals 100 c.
What number?
10. Oh, it's really 2250 times 250. So 225 times 25 times 100 and back. We will rock you. Ba-dum. We will rock you. Bada. 10,000 is going to become 2,500. I'm sure we could simplify it more, so let's divide by 4 once again. To get 4 times cx squared plus cy squared is equal to 25 cx squared plus the humongous 5625 times 25. This is going to become very messy, very quick. Which is 15625 plus 125,000. So 140625 minus 7500 CX comes 75 times 25, which is just 625 times 3, which is just 1875. It's still very laborious to simplify. So I don't know about this. The area of ABC is 100 square units. Now, this might be an even harder requirement to satisfy, because that will mean that CY, 10 CY divided by 2 is apparently 100. So 5 CY is 100, so CY is 20. Okay. But we've already established a y coordinate that it must be on. So if CY is 20, that gives us 4CX squared plus 400 equals 25 CX squared plus 14625 minus 1875 CX. I really don't want to do a quadratic with these coefficients, but I think I have to settle for it. Okay, so that means 21 CX squared. 21 C100, which barely even makes a dent. Minus 1875 CX. No. Oh, God, no. Oh, Jesus. Oh, no. Oh. Why do I have to factor this? Okay, the area of ABC is... Okay. Well, whatever it is, there are only going to be 2 solutions to this thing. So might as well just put B. Then again, I never did consider negatives, which work much the same way. So is it 2? No, it's actually probably 4. Which makes it C. Two jars each contain the same amount of marbles. Each marble is either blue or green. Jar 1, the ratio of blue to green marbles is 9 to 1. And the ratio of blue to green in jar 2 is 8 to 1. Or 95. Okay, can't be that hard. So that means that 9/10 of jar 1 is blue, and 1/10 of jar 1 is green. And likewise, we have 8/9 of J2 is blue, and 1/9 of J2 is, well, now that I think about it, they both contain the same amount of marbles. So might as well put just J instead. So 1/10 J is the amount in J1, and 1/9 J is the amount in J2. Apparently this is 95 in all. So 9 over 90 plus 10 over 90 is 19 over 90 times 95. So 1 over 90 J is 5. So J is 450. So that means that there are 9 times 45 marbles, blue marbles in J1, while 8 over 9 times 450 is actually 8 times 50, which is 400. So 9 times 45 is 450 plus 45, which is 495. Oh no. Seem to have made a critical error. Wait, 45, 450. Wait, no, I'm dumb. Oh no. 40 times 9 is 360. So it's 405. Oh, 5. 5 more marbles. Okay, what's the greatest possible sum of the digits in the base 7 representation of a positive integer less than 2019? We are farmers. Let's try representing 2019 in base 7. First of all, I'm pretty sure 7 to the 4th is somewhere like 2601 or something like that. Regardless, it's got to be greater than 2019. So 7 cubed is 343, so that should work. So 343 times 6, let's see where that ends up. 1800 plus 240 plus 18. So 2058. Never mind. Okay, we're using 343 times 5, which gives us 1715. So that's in our first spot. 1715 minus. I'm already gravitating towards. Excuse me. Wouldn't it just be 666? Because that's a number in base 7, right? What does it even represent? Six times 57 is 342. Yeah, that's a very real number. So that means it can't be anything less than 18. I don't know how you would even get up to 22. Because if you have a 6 in the thousands place, that immediately means that it's greater than 2019 in base 7. Unless I'm goofing. Yeah, I don't see what is quite going on here. Yeah. Shouldn't it be 18? Ow, ouch, eat. Well, 18 is not an answer choice, but it's possible. 342, I would say, is a positive integer. Wait. Wait, no. 342 plus 1. Am I representing it wrong? And 343, as we all know, is 1000 at base 7. So I guess, oh yeah, like 999 is, okay, it makes sense. But, okay, what's 2019 in base 7? Let's work on that. This is 304, I think. So we'll put a 0 there. Minus 49, I think, can be multiplied by 6 here. So to get 294, so that's 10 remaining. So 10. Wait. Oh, shoot. I placed them wrong. Oh, this is the ones, tens. No, well, this is 1, this is 7, this is 49, and this is 343, and then, okay. So 5. Okay, so we need 5 343s to come in, first of all. Yeah, that's right. Then we have 304 remaining. How many 49s go in there? 6. That leaves 10 left. That's 1 7 and 3 1s. This is the base 7 representation of 2019. Now, I don't see what I'm supposed to do here. Oh, well. 5566? Does that work? It might be a little larger. I don't think it is. 6 1, 6 7s. That's 1 plus 42, 6 plus 42, which is already 48. And then these are for the 49s. So it's 490 over 2, which is 245. So that's 293 in all. Plus 343 times 5, which we calculated was something like, what was 1715? Shouldn't it be, can't be 1715, 300 times, oh yeah, that's right, I was thinking of 343 times 6. So, 1715, right? And that makes 2012. Unless I'm really dumb. I am really dumb, never mind. It's 2015 minus 7. So probably 1998. No, I'm dumb. It's 2003. Took me a little bit to get it right. 2003, 2008. Oh my god. Yeah, okay, I think that's finally correct. So, does this really represent 20? Yeah, okay. And then, yeah, 22. We can't get a 7 anywhere here. The next number here is going to be 5600. So, yeah, and then it's never going to be bigger than that. So my grand pick is going to be C. This is a lot of work. What is the sum of all real numbers x for which the median of the numbers 4, 6, 8, 17, and x is equal to the mean of those 5 numbers? Casework. Scenario 1. X 4, 6, 8, 17. So the median is 6. So that means that, what's the sum of 4, 6, and 8, and 17? 35, I'm pretty sure. So x plus 35 over 5, or x over 5 plus 7. If it's 6, then x is negative 5. So negative 5. So 4x6, 8, 7, 17. Well, actually, we've studied this scenario before. The median is still 6, so doesn't really make a difference. 4, 6, x, 8, 17. Here the median is x, so that means x over 5 plus 7 must be x. And that means that 7 is 4 over 5x, and x is 35 over 4. And in this case, I think this is the final one we need to study. 8 is the median. So x over 5 plus 7 is 8. So x over 5 is 1, x is 5. But wait a second, that scenario doesn't work, because that would mean that 6 is the median. So no, there's nothing that works here. So the total sum should be 15 over 4. So I'll pick D. The base 10 representation for 19 factorial is very big, where t, m, and h denote digits that aren't given. What is t, m plus h? What's the prime factorization of 19 factorial? Since it's only 19, it wouldn't be that hard to prime factorize. Let's see, what are all the primes? Okay, now we're going to add all of the regular numbers. So 4, 6, 8. Wait, no way, I just said 8 is 2 to the 4. 9, 10, 12, 14, 15, 16, and 18. Okay, so let's circle all the primes around here. First of all, everything after 7 only appears once, so we'll just put them at the back, or the front, I guess. Then we'll cover 2, which appears, well, let's circle. Wait, let's circle it based on what the exponent is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so for the 3s, I'll use a different color. So 1, 2 circle, 3, 4 circle, 5 circles, 6 circles, 7, 8 circle. So 3 to the 8. Now when we're circling 5, let's use blue. I know 7 only appears twice, so 5. So 1, 2 circle, 3 circle. Oh, come on, we were just about to have a really nice, cool looking pattern. Could have been cool if it was 2 to the 16, 3 to the 8, 5 to the 4, 7 to the 2. No, you just had to ruin it, 5. Okay. So here, 2 to the 16, 5 to the 3, that means that there are 3 zeros straight at the back. So that means 8 is just a 0. Now, finding m might be a little bit tricky, because right now we have 0, 0, 0. We have 10 to the flabba-jabba, 10 to the 3, 2 to the 13, 3 to the 8, 7 to the 2, 11, 13, 17, 19. This will be relevant later, I hope. No, they'll already play a big part here. This sucks. No, if someone went really crazy They could just do it with arithmetic. It would be very funny. So from what it appears, it could be divided by 8 to provide something desirable. Yeah, yeah. Yeah. Hmm. So what's the number without the zeros? 121 6T5 10040M832. Jesus Christ. You know what? It can't be that bad. Famous last words. Now that all the 5s are gone. 2 to the 13 is not 65536, not 32768. That's 2 to the 15. 2 to the 14 is 16384. 2 to the 13 is 8192. So 3 to the 8 is 81 times 81. Man, this is such an incredibly stupid idea. Where did I even come up with this? Why am I doing this to myself? I'm going to multiply 11, 13, 17, and 19. 13 times 11 is 143. Very easy. 143 times 19 is 2860 minus 143, which is 2760 minus 43, which is 2717. So then 2717 times 17 is, well, 7 times 7 is 49. 7 times 1 is 7 plus 4 is 11. 7 times 7, okay, 49. 7 times 2 is, okay, this is definitely not the intended route, but it's the route I'm taking. 98161 46189. So what did he do? Wow, this is such an incredibly dumb thing to do. Mistakes happen everywhere when you're doing arithmetic, and it's generally just so boring. But this is my last ditch attempt to actually get 14 correct, because I really don't want to get it wrong, and I like some cheap points. 6 times 1 is 6, plus 5 is 11, so 49. 5 times 2 is 10, 46, 6, 40. And then 2, 5. Okay, 2, 7, 9, 15, 17, 20, 21, 7, 13. Okay. 5, 3, 7, 1, 7, 7, 1, 2. Right order of magnitude. Okay. 49 and 416 46189. I have made such a big, massive mistake by even just trying to outsmart this. 9 times 9 is 81. 9 times 8 is 72. 17. 55. 36. Man, what am I doing? So 4 times 9 is 36. 4 times 8 is 32 plus 3 is 35. 4 times 7 times 6 is 24. 4 times... Okay. God. So I'm multiplying this behemoth with this behemoth. No. The day of reckoning has come, boys. Okay. So supposedly this number should at least end in 832. So if all of the unhidden digits are correct, I will be not only very proud of myself, but I will also trust myself that the hidden digits are all correct. No. Oh God. 12. 6, okay, 7. Things are going to go so slowly. 6 times 7 is 42. 6 times 7 again is going to be 46. 6 times 10. 6 is 43. 22. 32. Oh God. Okay. Let me erase these. This is a lot of time spent for question 14. Over 2 digits, if that. T and M. So one funny thing you can do is actually just reuse these. The only new ones we're going to have to do are 3 and 2, and then we can just repeat 6 and 2. You'll see what I mean soon. So what's 2 times 2? 4. 2 times 1, 2. Oh my God, 832. Ooh, thank the Lord. Okay. So 7, 2. 2 times 2 is 4. 2 times 1 is 2. 2 times 7, 14. 15. 3. 14. 7. 10. Hallelujah. Okay, now last one we need to do is 3, and then all we gotta do is add. 3 times 2 is 6. 3 times 1 is 3. 3 times 7 is 21. Man, I'm so sorry for all my poor viewers who have to watch me go through this. 5. 3 times 7 is 21. I'm making some subtle mistake somewhere. I can feel it. I can just feel it. And I'll have no time to go back and look for it and fix it. I've only got one shot at this. Times 3 is 9. Plus 2 is 11. So 16. Wait, this is 3. Okay, everything checks out, so now we're just going to repeat these. Still have to do 6. Wait, no. 2, 6, 1, 3, 6. Okay, this is gonna be 2, and this is gonna be 2 again. So I think you can see what I'm going to do here. Okay, so what I'm going to do is, let's put just the entirety of 6 here. 2. So, no, I feel like I'm going to make some sort of reading or transcription mistake. There are so many, way too many places where this could go oh so wrong. 062 3223. Just to keep it from cramping up too much, I'm going to move these 2 down. Okay, and let's draw the big line to prepare. Okay, 10, 7, 4, 3, 5, 4, 2, 4. 107, 4, 3, 5, 4, 2, 4. So let's write the 4 first. Done. 2, 4, 5, 3, 4. 107. 701. Oh my god. And the final one, boys. We've finally got there. All we need to do is write 424 435 107. Oh god. The day of reckoning has arrived. 2, 3, 18. 1 plus 7 is 8. 8 plus 2 is 10. 10 plus 2 is 12. 18. 1 plus 1 is 2. 2 plus 6 plus 4 is 12. 12 plus 3 is 15. 17. Okay, this is done. 1. 1 plus 7. 1 plus 7 is 8. 8 plus 5 is 13. 13, 16, 13, 14, 21, 25. Oh no. 3, 3, 3, 3, 12, 14, 16, 18, 22. I don't even know. Woo! Okay. Damn it. It's very clear that I made a mistake somewhere, somehow. Damn it. Worked so hard. I was really hoping it was going to be right, but oh well. You win some, you lose some. 15, 24. I don't know. I'm not gonna do anything. I'm just gonna give up and guess. No, skip. T1 and T2 have areas 1 and 2 respectively. Okay, so let's say we have do it and D. So right now we have A here is going to go into A, and let's say this B is going to be here. Okay, so let's call this C. C is equal to the square root of A squared plus B squared. Let's call this D. So what's the square root of B squared minus A squared times B squared plus A squared? Well, it's B to the fourth minus A to the fourth. Man, I love differences of squares. So now we know that A times D is 2, and A times B, well, 2AB is 1, and 2AB, yeah. So A root B to the fourth minus A to the fourth is equal to 2AB. Just wanted to let you know. So A, want to cancel that out actually. So B to the fourth minus A to the fourth is 2B. So B to the fourth minus 2B is A to the fourth. So what I'm thinking of here is this. So these two triangles have areas 1 and 2. So AC is 1, and AB is, well, half AC is 1. So AC is 2, and AB is 4. So that makes me think something actually. C is half B. So now what is C actually? C is the square root of B squared minus A squared. So 3/4 of B squared is A squared. Wow, C's. And root 3 over 2B is A. Nice. That is some new intel. So root 3 over 2B squared is 4. Is 8 root 3 over 3. A squared is 3/4 of this. 2 root 3. So C is the square root of B squared, so 8 rad 3 over 3 minus A squared, 2 rad 3. So C is the square root of 2 root 3 over 3. So what we're going to do now is D is the square root of B squared plus A squared. So B squared plus A squared. Engaging in malfeasance and mischievous activities. So C times D, the product of these two sides, is rad 2 root 3 over 3 times rad 14 root 3 over 3. So C times D is equal to rad of 2 times 14 times 3 over 9 equals 2 times 14 over 3. Oh no. Oh, the square of the product. Thank God. Thank God. Oh. Okay. ABC with right angle. C point D lies in the interior of. Okay. Okay, so point D lies in the interior of AB. That's it. Okay. AC is equal to CD. Let's see. DE equals EB. Oh God. Okay. Let me try drawing a better looking diagram. CA. DE equals EB. Oh no. Wait, but wouldn't that mean E is... Oh, it's because my two sides look like they're the same length. Now this should definitely provide a good looking diagram. A few minutes later. Okay. So then this is D. DE equals EB. Okay, that finally works. And the ratio AC to DE is 4/3. No, 4 to 3. Probably either B or D, because I find that the length of the hypotenuse is 16x squared times the square root of 5. 16, well, no, 16 root 5x. No, 4 root 5x. Wait, now that I think about it, this is a similar triangle to. Wait, so 4 root 5 is to 3 as. So the big is to the small as the big is to the, let's call this length right here x. No, let's call it L, actually. So that means 3 over 4 root 5 is L over 4. So that means that L is 3 root 5 over 5. I'm so sorry. This is 3 root 5 over 5. So this is twice that, 6 root 5 over 5. And this whole thing is twice that, 12 root 5 over 5. And I guess same principle applies here, which would make this. So that means 4 root 5, which is 20 root 5 over 5, minus 12 root 5 over 5 is 8 root 5 over 5. So that means the length of AD is 8 root 5 over 5. Length of DB is 12 root 5 over 5. So it's 8 to 12. So that's 2 to 3. Nice. Okay. Okay. Red ball and okay, I'll be honest with you. I have seen this one before, so I'll skip it for you guys. Harry decides one morning to do a workout, and he walks 3/4 of the way from his home to his gym. The gym is 2 kilometers away. Well, kilometers, not kilometers. Kilometers away from Henry's home. Okay. So 2 kilometers. He's already walked 1.5 kilometers when he changes his mind. He reaches this idiot. Oh, this guy is just going to keep going forever and ever, bro. Okay, so point A kilometers and point B kilometers from home. What's the distance between A and B? So let's see. Well, his first cycle, he's going for 1.5. Oh, wait, okay. What I'm thinking here is what he was doing is he was taking 2 minus 2 over 4, and then you take this and you subtract it by this same thing over 4, and you take this and you subtract it by this same thing divided by 4, etc., etc. So essentially, it's like multiplying by 3/4. 2 times 3/4 times 3/4 times 3/4. So So yeah, so that's like the distance, the chunk that he bites off. So the first time he goes for 2 times 3/4, then he goes back for 2 times 3/4 times 3/4. Then he goes forward 2 times 3/4 times 3/4 times 3/4, etc. He's gonna keep going back and forth, but eventually this is going to become smaller over time. Okay, let's assume we have A and B, and he's basically just stuck in this endless loop, right? So, like, he starts from A, and he's 2 kilometers away from the gym. So this distance right here is 2 minus A, correct? So then 2 minus A times 3/4 is apparently equal to B. So then he goes to B, and he tries to walk his way home. This distance is B, obviously. But then once he's gone 3/4 of the way in, he goes back to A. So that means 2 minus A times, so 3/4 B is A, so B is 4/3 A. So 2 minus A to the 3/4 is 4/3 A. So 3/2 minus 3/4 A is 4/3 A. So 3 over 2 is 4 over 3 plus 3 over 4 times A. 3 over 2 equals 16 over 12 plus 9 over 12. I hope, anyway. So 25/12. So 12 over 25 times 3 over 2 is 18 over 25. So that's A, 18/25 of a kilometer. So where's B? Well, B is 4/3 A. So B minus A, or 4/3 A minus A, is 1/3 of A, which is 6/25. Wow. It's unexpectedly small, actually. What? I don't see it. I don't see the solution here. Because I feel like I've already got my solution, but apparently it's incorrect, right? He won't keep walking between 18 over 25 and 24 over 25? Well, let's test out this scenario. So oh yeah, that's right. Okay. So what went wrong here? Let's try this scenario again, because I'm sure my method is right. This is probably a computational error. So this length is 2 minus A, yep. So 2 minus A, he goes 3/4 of the way. Oh, it's this length A plus B. Oh, darn it. I should have considered that. And then once he reaches B, he can't help but go back all the way to A. So so he goes 3/4 of A plus B backwards, which means that 1/4 A plus B is A. Oh my gosh. So A plus B is 4A. So 4A is equal to 2 minus A times 3/4. So 16 over 3A equals 2 minus A. A is 6/19. And B, meanwhile, what is B? B is 3A. So the difference is 2A. Oh, that's still less than 1. Darn it. It's very, very close to 12/18, though. And 12/18 is 2/3. So I'll pick A, personally. Okay, let S be the set of all positive integer divisors of 1000. How many numbers are the product of two distinct elements of S? Oh, I thought that was a phone call. 2 to the 5, 5 to the 5, prime factorization. So the set of all positive integer divisors, that contains 36 integers. So, what's the maximum product, actually? That's what I'm going to ask. 2 to the 5, 5 to the 5 is 2 to the 5, 5 to the 4 multiplied together. It's going to be our maximum product. Or rather, 2 to the 5, 5 to the 5 times 2 to the 4, 5 to the 5. Whatever. So 2 to the 9, 5 to the 10 or something like that. So A and B, so this power and this power can be anything from 0 to 10, except they both can't be 10 and they both can't be 0. So that's already 11 times 11 minus 2 cases, which is 119. Hell no. I'm not even going to try. No. Nope, not possible because of graphing the tangent lines. Gonna see what the factors of that are. X plus 1 times x plus 4 over x plus 6. Yeah, no, I'm gonna skip problem 24 and definitely problem 25 too. Okay, I'm really hoping I got above 108. Tried as many questions as I possibly could. A. Oh no, 10 I got wrong. Apparently it's A. 11, A, 12, C, 13. Oh no. Nervioso. Let me solve this equation real quick, because I'm real nervioso right now. Q plus 25 is 108. 1.5 times 3Q plus 25 is 108. So 216 over 3 is 3Q plus 25. That's 36 times 3, right? So that's 108. Wait, no. 36 times 2, which is 72. 72 minus 25 is 3Q. So that means Q is almost 16. Oh no. Probably didn't get it, but it's fine. Come on. That's a bitter ending. Okay. Let's see. That's 1, 2, 3, 4, 5, 6, 7, 8 skips. 12 points plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is 84 points, which is sadly only 96 points. What's 108 minus 96 is staggering 12. How did I get 10 and 13 wrong? 10 and 13. If I was brave enough to try it, then it couldn't have been that bad, right? What? No chance 10 is A. What? Lord. Oh! I must have gotten like an imaginary number or something. Okay. So I did a dumb. Oh. He did basically the same exact thing I did. Oh well. What about 13? Is it not D? What? Oh, I didn't notice that. Sis. Okay. Well, that's it. Thank you everybody for watching. Those were some two very hard. Those were some two very easy questions that I sillied. Well, thank you everybody for watching. We'll see you in the next one.